2014 NCEA 2 calculus exam. Let's do 1e. So we've got this function here, which is g of x, and it says for what values of x is g a decreasing function. Now this is a positive cubic, so it's going to look something like there. And we can see here that the gradient here is 0 and the gradient over here is 0. So that value there, gradient is 0. And that should be like there, sorry, it's at the top. And this value, the gradient is 0 as well. There it is. The question is where's it decreasing? Well, it's decreasing where the gradient's decreasing. It's decreasing a little bit there, it's decreasing a bit more there, decreasing a whole lot more there, decreasing even more there. And then it starts to stop decreasing in the middle there. There's the point of maximum decrease. That's called the point of inflection. Then it's going to get progressively less decreasing. So here it is. The decreasing is just fading out a little bit. Less decrease, less decrease, less decrease until it gets to the bottom when m is 0. So it stopped decreasing, and after that it starts increasing a bit more. The gradient's a bit more, and so on and so forth. So that's really what we're doing. We're going to find where it's decreasing. It's decreasing between here and here. The question is, what is this x value here? What is this x value here? That's what we've got to find. Okay, so let's go ahead and do just that. So we're going to say, first of all, let's write out the function. We've got g of x is equal to 2x cubed on 3 plus 3x squared on 2 minus 20x plus 4. So I'm going to find the gradient function of that, or the differential function, set it to 0, and then it's going to reveal these two x values. Let's see if that works. So here we go. So g dash x, or g prime x, is equal to, and I'm going to write this out and differentiate as I go. So I'm going to have 2x on 3, but I'm going to increase the power by 1, becomes, decrease the power by 1. What am I doing? So it's going to be 2 times 3 is 6. So I'm already messing up. So it's not good. So 2 3s are 6. Leave the 3 there. And decrease the power by 1. Plus 3 2s are 6. And I've got a 2 on the bottom. And I'm going to have 20 here, decreased by 1. This leaves me with a 20. And there we are. So let's tidy this up now. So I've got g dash x is equal to 3 goes into 6 twice, plus 2 goes into 3, 6 3 times, minus 20. So there is my function. And this is my gradient function. So we want to find out the values for x. So the whole point of doing this was to reveal x. So if we make this equal to 0 and then we factorize, we'll have two values hopefully for x. Let's see what they are. I'm going to factorize by division. Here we go. So I've got a 2x here and a 2x here. So 2 times 20 is 40. I'll write this out here. So 2 times, I'll write it next to here. 2 20s are 40. Facts of 40 are 1 and 40, 2 and 20, 4 and, what do we got? 10, 5 and 8. Look, there, I've done it. 5 and 8, well, 5 minus 8 or 8 minus 5 in some order will give me a 3. Now, the signs are different. The biggest one's going to be positive. Which is the biggest? So signs are different. Biggest is positive. Which is the biggest number? Oh, it's 8. 8 goes next to the positive. 5 goes next to the negative. All right, let's see if I can do anything with this. Oh, I can divide this by 2. Can't divide that by anything. So 0 is equal to, 2 goes into 2x. X times 2 goes into 8 4 times. And I'm left with a 2x minus 5. There we are. So now I've managed to factorize it successfully. Now, so therefore, if this is true, x must be equal to negative 4, or x must be equal to 5 on 2. There we go. Or 2.5 if you like. Now, again, we go back to what we found here. So we've got our cubic, and we don't know what it looks like. It could be anywhere here, up and down, but we do know that at negative 4, here's my negative 4, it's going to be, because it's a positive cubic, that's going to have something around here, and at 5 over 2, or if you like 2.5, which let's just call it 2.5, is there, it's going to be heading downwards here. That's going to be this point here, yeah? So that's really where it is. So this is going to be the maximum. Yeah, that's going to be my maximum. And over here at 2.5, is going to be the minimum, yeah? And of course, this will of course all join up like somehow like that. Now, of course, that's decreasing, as you can see from here to here, but we need to show that. And there's lots of ways you can do it. One of my favorite is to draw the gradient function graph. So let's draw that now. Here it is. So we've got a 0 in the middle. We've got our -4 over here. We've got our 2.5 over here. There it is. And I can now draw that parabola. Here it is. It's just a little parabola. It goes down, turns around, and heads back up. There it is. There's my parabola. And this time we're no longer doing x versus y, because this is x versus y. This is, if you like, f of x, or if you like, m, yeah? Or sorry, g of x, or say g dash x. This is our gradient function versus x. So now what we're looking at is whenever we have the values that are below the x-axis, this represents decreasing values of x. On the other side here, we've got increasing values of x, yeah? And these are also, I'll put over here as well, increasing values of x, yeah? All right, so this is how we know that. So we know it because we've got put here decreasing values of x. And I think that would do it. I don't think you need to draw any more. I think this is pretty conclusive that you understand what you're doing. And therefore, I would conclude by saying, therefore, x for the function g of x, x is decreasing, ... and I'll put x, it's going to be when it's less than 2.5 and then when it's greater than -4. And that would be my solution. I think that's really all you need to put. And I think that makes it pretty clear what you intend.